Greetings and welcome back to Tuesday and Wednesday's edition of Mr. Long's Distant Learning for the Advanced class. Our lesson for today is 9.4 Measures of Variation with the accompanying homework on eCampus. Take a look at our learning goals to develop an understanding of statistical variability and to summarize and describe data distributions. Our goal today is learning goal 6-12. Let's take a quick moment to remind ourselves the steps to finding mean, median, and to make box plots and finding mean absolute deviation. Pause the video now and take any notes that you would need to have these documented. Again, use this as a reminder to help you solve some of the problems later in an upcoming quiz. Let's continue. Let's get started by asking this essential question. How can you describe the spread of data? A measure of variation is the measure that describes the distribution of a data set. A simple measure of variation is to find the range. The range of a dataset is the difference between the greatest value and least value. This table shows the length of several Burmese pythons captured for a study. Find and interpret the range of the lengths. Now the appropriate step to take is to sort these numbers from least to greatest. However, we can just find the range by looking for the least value and the greatest value. In this case, 5 is the least, and it looks like 18.5 is the greatest value. The difference of these values is 13.5. Let's check to see if our confirmation answer is right. After sorting these, we do find that it is the least and greatest value. So the range will be subtracting finding the difference. This means that the length varies no more than 13.5 feet. The shortest python that was captured was 5 feet, and the longest was 13.5. The differences are 13.5 feet. Now it's your turn. The ages of people on land for a roller coaster are 15, 17, 21, 32, 41, 30, 25, 52, 16, 39, 11, and 24. Find and interpret the range of their ages. Pause the video now to see if you can find the range accurately, and then resume the video once you've completed the task. Welcome back. Were you able to discover the range appropriately? Let's find out. The range was 41, subtracting the smallest value from the greatest value. In this case, the youngest rider on the roller coaster is 11 years old, while the oldest person in line for the roller coaster is 52. That would mean that the age of the people in line vary by no more than 41 years. Just as we did with the box plots, quartiles of a data set divide the data into 4 equal parts. Recall that the median, the second quarter, because it's in the middle, divides the set into 2 equal halves. We call this the first quarter, the second, and the third. Our fourth quarter actually gives us a whole list. Again, the first quartile is the median of the lower half. You can say the middle of the left half. And the third or upper quartile is the middle of the right half. The difference between the third and first quartile is called the interquartile range. Remember, range is the difference between the least and greatest values, so interquartile range is the range between the interquartiles here and here. The interquartile range represents a range of the middle half of the data and is another measure of variation. In this case, the interquartile range is between 32 and 22. By subtracting, this will give us an interquartile range of 10. Let's apply all this knowledge to work on an exercise problem. Let's have a look. The dot plot shows the top speeds of 12 sports cars. Find and interpret the interquartile range of the data. Now that we have a dot plot, we know that each of these values represents a certain number in miles per hour. What do you think this dot here that I'm highlighting represents? What speed? You guessed it, 245 miles per hour. Do you think you can make a list of numbers from least to greatest using all these dots? Let's take a look. We'll order the speed from least to greatest and find the quartiles. Do note that there are 12 dots here, so there are going to be 12 numbers in this list. 12 is an even number, so there will not be an exact middle number. Remember the rule of finding a median for an even number set? That's right, it's to add the 2 middle numbers up and divide by 2. Our median would then be 247.5 miles per hour. Can you guess the lower quartile between 230 and 240? How about the number between 250 and 260? Correct again. You can probably figure it out without doing the math. But remember, the steps are to add the two numbers together and divide by 2 in both instances. So what is the interquartile range from 255 to 235? That's right, the interquartile range is 20. This means that the middle half of the speeds vary no more than 20 miles per hour. Again, it's the middle half of the speeds because 50% of the data is between the lower and upper quartile. If each section is 25%, and the box plot or the interquartile is two sections of 25 make 50% or half the speeds. Now what if there was a sports car that traveled 500 miles an hour? Or if you can qualify a car as a sports car if its top speed is 90 miles per hour. Would those be considered outliers? Let's take a look. You can use the quartiles and the interquartile ranges to check for outliers. Any value less than 1.5 or 1.5 times the interquartile range is an outlier. Any value greater than 1.5 times the interquartile range is an outlier on the greater end. To find this outlier gap, you must first find the interquartile range. Then you multiply it by 1.5. Subtract that value from quartile 1. Anything less than that is an outlier on the low side. Take that value after multiplying by 1.5, the interquartile range, add that to quartile 3. Anything greater than that is an outlier on the high side. Let's take a look at an example to highlight this outlier using the math in the steps below. Going back to our sports car example, let's multiply the interquartile range, which was 20, by 1.5. 1.5 times 20 is 30. 235, the lower quartile, minus 30 gives us 205. Let's do the same thing on the other end. The upper quartile is 255, and again, I'm going to add 1.5 times the interquartile range. 255 plus 30 is 285. From this list here, are there any speeds lower than 205 miles per hour in this list? Are there any speeds greater than 285 in this list? Since there are none, the data has no outliers. Let's examine this a little bit closer. Pause the video now and write down any questions you might have that can be answered in the email. All right, folks, let's try one of these questions on your own. The number of pages in each of an author's novels is shown. That means the novel of this author has books of 356 pages, 364 pages, 390, 468, 400, 382, 376, 396, and 350 pages. I want you to find and interpret the interquartile range of the data. Does this data contain any outliers? Justify your answers. Go ahead and rewind the video to view the steps again on how to find interquartile range and to check to see if there are outliers. At this time, go ahead and try to work this out. Sort these numbers, find the interquartile range, and then see if there are outliers. Then resume the video once you've completed the task. Welcome back. Let's check our answers. Our first step is to sort these numbers from least to greatest. I bet some of you guys might have just tried to find the middle, left side middle, and right side middle without sorting them. We always have to remember to sort these from least to greatest to get an accurate measure. Do you remember the example we did in class trying to find the median height of the students in the class? Could we just pick the student that sits in the middle of the class, or should we sort them from lowest to tallest before we find the median? This is just the same case, how to sort these numbers first. At the moment, you can tell that there is an exact median because there are 9 numbers in this set. There is an odd number, so there's going to be an exact median of 382. This will then split the list into 2 halves, with 4 numbers on each side. That would mean that the lower quartile, or first quartile, is between 356 and 364. By adding these 2 numbers up and dividing by 2, we get a lower quartile of 360. Performing the same method, we have to combine 396 and 400, divided by 2, and we get an upper quartile of 398. So let's find the interquartile range. Do you remember how to do that? Remember, it's just finding the range between these quartiles by subtracting. The interquartile range will be 398 minus 360. Our result will be 38. Interpreting this means that the middle half of the numbers of pages vary by no more than 38. You can use this explanation for other questions, especially the ones posed in the homework, by just changing the context. It'll always be the middle half of the, and whatever part of the story says, continued by, vary by no more than, whatever the interquartile range is. Let's find if there are any outliers. Remember the steps. We must find the interquartile range first, which we have, which is 38. Multiply this by 1.5. We get 52. Subtract that value from the first quartile. 360 minus 52 gives us 308. Add this to the third quartile. 398 plus 52 is 450. This is the range of numbers that we can have. Any numbers lower than 308 or higher than 450 is an outlier. From this list, do we have any numbers that are lower than 308 or any numbers that are higher than 450? You guessed it, yes. The boundary for the outliers are from 308 to 450. None of the page numbers are less than 308, but one value, 468, is greater than 450. So 468 is an outlier. Let's see if you can take this knowledge and apply it to complete the homework 9.4 on eCampus. Remember, you can rewatch the video at any time, pause and take notes, and try the practice problems while you watch. I look forward to seeing your homework submissions. Until next time.